morning, my students. Today we will start with the polysaccharides. So in the last class we have started with the chemistry of carbohydrates. So in the chemistry of carbohydrates we have defined what is carbohydrates and what is the classification of that and what is the properties of carbohydrates. So these are the things we have discussed in the last class. So till disaccharides we have explained in the last class. Today we will start with the polysaccharides. Okay? So as we all know that the carbohydrates are majorly classified. Carbohydrates is a major component that is classified majorly as monosaccharides, disaccharides and the polysaccharides. So polysaccharides again it is classified again into homopolysaccharides and the heteropolysaccharides. What do you mean by this? Polysaccharides, as the name indicating polysaccharide, it means it is made of large complements of monosaccharide molecules. It is composed of monosaccharide molecules. So that it has to link up with some molecule. How is polysaccharides is linked? So these are very large in size and it is linked up with the bond called as alpha glycogen bond. So this is the bond where the linkage of the monosaccharides with the others and forming the polysaccharides. So these polysaccharides are majorly classified into two categories. One is the homopolysaccharides and the heteropolysaccharides. So homopolysaccharides is nothing but so when the homopolysaccharides undergo hydrolysis, that means when is the homopolysaccharides undergo hydrolysis, the breakdown of these polysaccharides. So that yields the same components of monosaccharides. For example, we know that the examples for the monosaccharides are glucose, are example for that. So if the homopolysaccharides is hydrolyzed, so that will be from same kind of a molecule, the end product will be the same product. So that is called as a homopolysaccharide. So when homopolysaccharide undergo hydrolysis, that yields the monosaccharides. So this includes majorly glycogen, starch, dextrin, cellulose and ilenin are the major examples for the homopolysaccharides. So these are the examples for the homopolysaccharides. When it comes to the heteropolysaccharides, so heteropolysaccharides as name indicating hetero, that means different parts. So homo means same kind of parts. Hetero means it has a different molecule. So when the heteropolysaccharides undergo hydrolysis, so that it yields the different type of monosaccharides. It is called as a heteropolysaccharides. The example for this, so this will be includes along with the in the heteropolysaccharides. This is the glucopolysaccharide. This is the commonest form of heteropolysaccharides. So apart from that, so then we learn what are the characteristic features of the homopolysaccharides. So the most important homopolysaccharides are majorly glycogen. So this is the including in the man. This is the storage form of glycogen. We do that in the next classes in the carbohydrate metabolism. We will study about the glycogen. So the glycogen is a major source of energy in the body. It has been stored in the glucose will be stored in the form of glycogen in the liver, so that will be metabolized by the two hormones, majorly insulin and the glucagon are the two major hormones which will be metabolized and regulated by these two hormones. So when it comes to the plant homopolysaccharides, that will includes majorly starch, cellulose and the ilenin. So these are the plant homopolysaccharides. These are the example for homopolysaccharides. When it comes to the animals, the glycogen is a major homopolysaccharide. When it comes to the plant homopolysaccharides, include starch, cellulose and the ilenin are the examples for the homopolysaccharides. So next we need to study about the what do you mean by the glycogen. Glycogen is a animal starch. So that will be major stored form of carbohydrates in our body, majorly in the liver. So it is made up of large number of glucose molecules. So how these glucose molecules will be majorly linked with the bond called as alpha 1,4 glycosyl bond. This is the bond where each bond called as alpha-1,4 glycosidic bond. So like this, each glucose molecule will be bonded with the alpha-1,4 glycosidic linkage. This will be repeating unit. So this is called as a glycogen molecule. So it's a long chain of glucose molecules which is formed. So usually every 8 to 12 glucose units there is a branch point. So in these branch points, the glucose molecules will be, one of the glucose unit will be linear changed by the bond called alpha-1,4 glycosidic bond. After 8 to 12 glucose units, so there is a branching between the glucose molecules will be happens. So that will be by the major bond called as a alpha-1,6 glycosidic bond. So by this, we know that the glycogen is a major storage form of glucose and it is bonded with the alpha-1,4 glycosidic bond and along with the alpha-1,6 glycosidic bond. So this is the branch point of glycogen, you can see. So this is the linear chain, linear glycosidic bond which is formed. With the one glucose molecules, there is with the 6th carbon atom of one glucose and first carbon atom of the glucose molecules is bonded. So that is called as alpha-1,6 glycosidic bond. So this is how the branching point of glycogen will be happens. So thus the glucose molecules at the branch point involved in a 2 glycosidic linkage as a lead, as one is a alpha-1,4 and alpha-1,6 is the branching points of the glucose molecule. So this branch also continues linearly until the secondary branch arises from it of the 8 to 12 glucose units. So this is the branches and the reducing end of the glycogen molecule. This is how we get the glycogen molecule. So next, starch. So this is the second example for the Homo polysaccharides. So the starch is the most abundant source for the diet, but synthesized in the plants and by the process of called photosynthesis. So this will be the form of, this will majorly in the potatoes, tubers, cereals, lichens are the rich source for the starch. So the starch we can count as the nutrition products like the potatoes, tubers, cereals, lichens are the products where we can see the starch. Starch is made up of the large number of glucose units, but it contains two different types of molecules. So the glucose really contains two types of molecules. One is amylose and amylopectin. These are the two molecules we found in the starch molecule. So the amylose, first majorly amylose. So this amylose are the linear molecule, so which is made up of units linked up with the alpha-1,4 glycosidic bonds. So this is the linear molecule made up of glucose units which is linked up with the alpha-1,4 glycosidic bonds. So this is called by the elegant structure. The structure is similar to that of glycogen, but it has no branches. It is constitute about 15 to 20% of the starch will be present. So in the 100%, almost 20% of the starch will be composed of mainly with the amylose molecule. So this is like, you can see the structure of the amylose. And next is the amylopectin. So the major component which is present in this is amylopectin. So this is constitutes about 80 to 85% of the starch will be composed of amylopectin. As a lead, it's a linear portions in which glucose units are connected with the alpha-1,4 glycosidic bonds and which will be contains arising from the starting chain by the alpha-1,6 glycosidic bonds. So this will be the branch points are around 20 to 30 glucose units apart. So after 20 to 30 glucose units, the branching point will be occurs to the amylopectin. So this and the reducing end, this is how we can see the amylopectin. So next is the next example for the heteropolysaccharides are the Homo polysaccharides are the next. So next thing is not naturally occurring in the polysaccharides, but it is an isotopic product of starch. So hydrolysis is nothing but, so upon hydrolysis, the size of the starch decreases progressively until it is converted into a maltose. So the dead state will be majorly composed of the maltose molecules. So it is naturally not occurring in the polysaccharides, but the intermediate products between starch and the maltose are known as a dead states. So the formation, the intermediate product which is formed in between the starch molecule and the maltose, that that is called as a dextrine molecule. So the dextrine is a mixture of several products that is progressively by decreasing the molecular sizes. So they are generally divided on the basis of the colors with the ions. Majorly we will having myelodextrin, that will be the violet color, and erythrodextrin and acrodextrin. These are the based on the colors, based on the ionic reactions. It is classified into myelodextrin, erythrodextrin and acrodextrin. So these are the examples for the dextrin molecules. So the next examples are cellulose. So cellulose forms the structural framework of the plants, and it is straight chain molecules which is made up of link with the beta-1,4 glycoside bond. This is the example for the polysaccharides. So this is the structure of the cellulose molecule. So the bondage between each glucosinate again is alpha-1,4 glycogen molecule. So next, there is no enzyme capable of hydrolyzing this enzyme. So this molecule is bonded with the beta-1,4 glycoside bond. When it comes to the starch, that is with the alpha-1,4 glycoside bond. But when it comes to the cellulose, this cellulose will be bonded with beta-1,4 glycoside bond. So in this molecule, that cellulose molecule will not be digested in the human digestive tract, because the enzyme which has to digest this cellulose molecule will be absent in the digestive tract of the human being. Hence, this cellulose can't be digested in the human being in the absence of the enzyme which is required to digest the cellulose molecule. So therefore, we can't use this cellulose molecule as a source of energy for the body. So majorly we use as glycogen as the major source of energy. So however, cellulose provides the roughage in our diet and hence our movement by stimulating the peristalsis. So this majorly cellulose will also take for as a nutrition, but majorly it will be helping us for it will take as in the form of diet. So that cellulose will be helping in the bowel movement by stimulating the peristalsis in the stomach. So they usually will take the cellulose as a diet, and the enzymes which is required to convert it in the form of energy, that enzyme will be having the digestive tract for the absorption of this cellulose molecule. So next is inulin. Inulin is a next example for the polysaccharides. So this is present in the genus anti-Homo and some other plants. So this is a side chain molecule which is made up of majorly fructose. So already we discussed in the last class about the fructose. This fructose molecule will be present in the inulin molecule. That fructose molecules will be joined by beta-1,2 glycoside bonds. So this is how the inulin will be formed. The inulin will be formed by the linkage of each fructose molecule by the beta-1,2 glycoside bonds, and there are around 30 to 35 fructose residues will be present in each inulin molecule. So the molecular weight for the inulin is around 5,000. This is the molecular weight of inulin. So this is how the structure we can see of inulin. So this is the structure of fructose molecule which is bonded with the beta-1,4 glycoside linkage. So like cellulose, inulin cannot be metabolized by the human beings. So cellulose and inulin we can't digest in the human being due to the absence of the enzyme. So if it is injected intravenously, it is completely filtered by the glandula. So usually to know the function of the kidney, usually we use the inulin to know the function of the kidney. If it is injected intravenously, it is completely filtered by the glandula, and it is neither separated or reabsorbed by the renal tubules. So therefore, inulin clearance is used to measure the glandular filtration rate. So inulin can be used as inulin clearance can be used to measure the glandular filtration rate. So next is polysaccharides. So polysaccharides is nothing much with the polysaccharides. In the polysaccharides classified into Homo and heteropolysaccharides. In the homopolysaccharides, so when the homopolysaccharides and homohydrolysis, that molecules will be the same kind of the molecule, the end product will be similar. But when it comes to the heteropolysaccharides, so the heteropolysaccharides are made up of more than one kind of polysaccharides are monosaccharide derivatives. The most important heteropolysaccharides in the human beings are glycopolysaccharides. This glycopolysaccharide is also known as glycosaminoglycans. So the most important heteropolysaccharides you can see in the human being are the glycopolysaccharides. So these are present in the connective tissue and the mucous secretions. So these glycopolysaccharides you can see in the connective tissue. Majorly these are present in the connective tissue and the mucous secretions. So the glycopolysaccharides are often combined with the protein molecules. So the glycopolysaccharides usually combine with the protein molecule, meaning that they have three major macromolecules to be used as a nutrition for the body. One is the carbohydrates, proteins and the lipids. So this glycopolysaccharides again will be combined with the protein molecules. So example, we take hexamines. So here the carbohydrate molecule is like with the combined with the amino molecules. These hexamines and the ammonic acids are the prominent constituents of glycopolysaccharides. These hexamines and the ammonic acids are the major components which is majorly present in the glycopolysaccharides. So these are usually present in the form of repeating disaccharide units. So what are the important glycopolysaccharides? So the major important glycopolysaccharides are hyaluronic acid, chondroitin sulfate, heparin sulfate, gametine sulfate and glycogen sulfate. These are the examples for the glycopolysaccharides. The glycopolysaccharides are the examples for heteropolysaccharides. These are we can give the examples for the hyaluronic acid, chondroitin sulfate, heparin sulfate, gametine sulfate. So these are we can give the examples for the glycopolysaccharides. So first we'll see about the hyaluronic acid.